Hi everyone, I'm Gary Benson, G Benson on IRC usually. I work for Red Hat on the debugger team, basically on GDB for the past few years. And the project I've been working on is called Infinity.
You turn the mic up, I can't hear you very well.
It's not attached to anything.
He has to speak louder.
Oh, right, sorry. Okay, I'll speak louder. All right, so first up, what is Infinity? It's a little kind of single sentence. It's a platform independent system for, basically, it's a platform independent system for applications to expose some extra functions to software development tools like, debuggers, monitors, and other analysis tooling. So, I guess throughout this talk, I'm going to say, Infinity is tool agnostic. It's not aimed at any particular tool, but I'm probably going to say GDB and debugger a lot because that's kind of where I'm coming from. So that's what it is. Why do we need it? Some aspects of some applications need to be kind of understood by the tooling you're using. So, for example, you may be working on an application and it's using multiple threads, and on your platform, the threading functionality is provided by libpthread.so, which is the threaded library. So if any tools that you then use to connect to examine this application, they need to know that if they see libpthread.so, if they see the threading library, then your application is doing something extra, and they need to do this extra bit, which for the threading library, there's a second library, the thread debugging library, which then the tool, the debugger or whatever, has to then find and load, and it can use these functions then to introspect your application and find out, in this case, the threads that your application is using. So in a kind of diagram, it looks like this. So you've got your application up there on the left, and the tool, the debugger, the monitor, is accessing your application somehow, and that's the red line. And the tool has loaded the thread debugging library to see what your application is doing with the threading library. So already there's a fair amount of knowledge that we're baking into that has to be baked into the tool to make all this work. So any tools that are going to deal with threaded applications here need to know that if they see the thread library, then they need to load the thread debugging library. And they also need to know that if your application is statically linked, then it may be threaded anyway. So it may need the thread debugging library anyway. The tools all need to know where to find the thread debugging library that relates to the threading library that you've loaded. And there's no standard way to do all this. It's just a pattern. So the libthreaddb, the thread debugging library, is just one example of a debug library. It's probably the most common, but there are other debug libraries that are used to examine runtime linker internals, and the OpenMP, the parallelization stuff, is either proposing or have written their own debug library. And this kind of stuff has to be, each debug library has to be written kind of individually, and the rules for finding the debug library have to be written, and also for how to check kind of versions, like the threading library and the thread debugging library are kind of, the thread debugging library is looking at internal structures in the threading library, so they have to make sure that they're for the same versions or whatever, and the same compiler. And all these issues can be, and they are currently handled. The thread debug library works, and it has for however many years it's existed, for most situations. So, if I go back to this is the graphic we just looked at. So the tool, the application, and the two libraries. But this picture's not complete. in here also is the C library, the system C library. So your application is linked to the C library, the threading library is linked to the C library, and your tool is linked to the C library and also the thread debugging library. And this is fine if you're using like a homogeneous environment, if you know everything's running on your laptop or everything's running on one computer somewhere. But it's not fine in a heterogeneous environment. So if you have different architectures, say, you know, your tool is running on your laptop and your application is on some ARC64 server somewhere, and it's also not, it also doesn't work in containers where maybe all this is running on the same computer, but the C library in your applications container is not the same as the C library in your tool container. And in this particular case, the C library is going to look like it's the correct architecture, but it may well be built for a different operating system, and it may well then just it may just crash your debugger when you load it. So this is kind of why I've been working on this project. Obviously, you can make special builds of the debug libraries that you know, it's built for this thread library, but it's linked against that thread library. But then you have a kind of matrix of different builds of the debug library that you have to maintain, and it kind of gets out of hand. So okay, so in order to kind of replace libthreaddb with something else, can I have a look at like what does libthreaddb do? Well, it has a bunch of functions that it exports to the tool. So they're all in the thread debug in terms of the functions that GDB uses in the thread debugging library. They're all they're all functions to get information about a specific thread, and there's a function that allows it to iterate over all the threads. But unlike a lot of other libraries, libthreaddb is kind of it's like double-ended. It exports functions to the tool, but it also imports functions back from the tool. So it's kind of importing amongst the functions for the tool. So the debugger or whatever would say, can I have the I don't know, the priority of this particular thread, and then the thread debugging library then comes back to the tool and says, okay, can I have the contents of this block of memory, or can I have this register from this thread? So the thread debugging library is essentially driving the debugger, the tool. Just kind of handing over the steering wheel to the thread debug library, just for a little while, and then it comes back with whatever the debugger has asked for. And the solution that I've kind of been working on for Infinity is to have platform-independent functions, the kind of equivalent of what the thread debug library has, stored in the actual library. So in libpthread, for instance, if you have your application is using the thread library contains the actual thread library code that it usually does, and as well it has these little functions that allow a debugger or a tool to call into it and say what is this, and it would come back. So this approach of having platform independent functions in the kind of regular library means that locating the functions is trivial. Like if your application is using this library, then the tool can see that here's the library, here's the actual file, the library that your application is using, and here in that file is these Infinity functions that I can use. It also means that the tools don't need to know that some particular library is accessed via some other particular debug library. If you connect to your application with a debugger and it finds Infinity functions to access certain threading things, then it knows that, okay, your application is maybe threading, so I'll maybe call these functions to find out what about it. I've gone ahead of myself a little bit. Yeah. Sorry. And also this method works nicely with static linking. It doesn't really matter where the functions are, where the infinity functions are. So if your library got its threading code from dynamically loading libpthread.so, then the debugger can see that. If your application got the threading library because it was statically linked in, then as long as the infinity functions have followed it, then the debugger can see that. And graphically, this looks like that. Sorry. Yeah, this is kind of that as a graphic. There's no kind of separate library. You just have your debug functions in the regular library. So, what can this be used for? The obvious first case is thread debugging, because that's the one that I've been kind of working on already. Another potential use is for when applications load libraries into different linker namespaces, which has been relatively uncommon on Linux, at least for up until now, maybe because it didn't work properly in glibc, but it's been fixed. So yeah, applications are basically, the debugger would, at the moment, if a debugger loads, if the application loads a library in a different namespace, then GDB at least won't see that. And there's no way for the C library, glibc, that has no way to export that. So as far as GDB is concerned, your program has gone off into some code that it has no idea what it is. Another potential use I mentioned earlier is OpenMP, which has its own debug library to access various things about what it's doing. ASAN and TSAN, address sanitizer and thread sanitizer from Clang. Is it Clang? Do people say Clang? Yeah. They currently use hacks to calculate things that are not exported, and these kind of things where a tool bakes in knowledge of the kind of internals of something else is a really, like, it's the kind of basic use case for it. And the final potential use that I thought of so far is pretty printers that glibc has. Like, currently they're written in Python, and the actual Python code has two parts. One part is the finding the thing you're trying to print, and the other part is actually printing it. So the printing bit is obviously would still stay in Python, but the bit of finding it and encoding all the structure offsets and stuff is really nicely suited for Infinity. So what are the components of this? There's a compiler which takes kind of a kind of textual source and turns it into dwarf bytecode wrapped in a little chunk that goes inside the binary or shared library. And there's also a tester which allows you to write unit tests, and it allows you to write basically a unit test and the function itself at the same time, which I kind of think is pretty important, because these functions are kind of for tooling. So like, you know, they're for software development tools, so that it puts a kind of like a late discovery of error into it, where, so say it could, if things like the thread debugging functions in glibc were not really going to be used in glibc until you start debugging an application with it. So it could potentially have a glibc gets built and shipped, and if it has a broken thread debug note, then the first thing you're going to find is if some user tries to debug something and the thread debugging is broken. So I wanted to make it as easy as possible for people to write complete test cases in the code they ship. The other thing, there's a client library which is it's written in C, and that kind of allows applications to kind of manage and execute the functions. And I've got currently a set of replacements for the libthreaddb functions that GDB needs. There's kind of 5 of them, I think. And there's also a lot of, since I last presented this, a lot of the questions were basically on the lines of, well, we'd really like to use this, but we'd also like to still have a libthread so that we don't have to change anything. So I've kind of also now I've kind of been integrating this into glibc's libthread so that if you are if you're trying to debug a program using glibc and you load libthread like normal, if your libthread has Infinity support and your glibc has Infinity support, then you'll use Infinity rather than the kind of existing setup. And
I was just curious, what role does the client library play? Like, what sort of?
It's a bytecode interpreter basically, but
And does it does it find the bytecodes for you? Because then don't you need that same kind of callback?
it doesn't. Yeah, there is a callback. It doesn't. The client library knows nothing about ELF, so I'm kind of anticipating that any program that's kind of looking at binaries and things has already kind of got some kind of ELF decoder in it. So you kind of provide the client library with the notes as just the blocks of data that are you kind of pass it the encoded functions, which are at the moment the only place to find them is in ELF notes. So.
But like you have to dig that out.
You have to dig that out.
Some kind of callback.
Yeah. I mean, it's not. I mean, even there's a certain amount of things like I'm going to dig myself in a hole here now because I mean, there's other stuff as well, like that. You know, if you're say you're a debugger, you're accessing this stuff. It's not just those bits of the ELF file that you need. You need other stuff that you need to be able to relocate it and stuff like that to be able to read the addresses. So it's kind of like I kind of thought of it as I can't think of an application that would use it that has not already got this stuff. I can't think the application could support libthread as it is without already having all this stuff. So any kind of other stuff is like extra or at least future. And I mentioned GDB integration is the last part. Initially that was kind of the final component and there was no wrapper inside libthread, but now the GDB integration is kind of into the past version 1.0 or whatever. So that's not a current thing. Kind of how long does this talk go? It's still 1/2 I'm gonna skip. I got some code, but I'm gonna skip it, I think.
You still have 20 minutes.
I still have 20 minutes. Alright, I'll make you look at the code. Anyway, I'll do it really quick because nobody wants to look at code. Basically, this is a function in libthread. It's getting the address of a symbol. It's doing some little special case logic with it, and that's what it looks like in C. And the Infinity version of it is basically the same length. It's getting it's loading the thing, doing the little special case. Do I go here? Do I go here? Do I go here? And that's it. So I'll not talk about that anymore. This I guess this sort of shows that what you will be writing if you're writing notes. So it's kind of the kind of general features. The functions have a name with a namespace. In this case, the function has one argument. The actual functions are written in dwarf bytecode, which I'm sure you all know what it is. It's a kind of stack-based language. So this function has one argument, which means when you arrive at the top of the function, the caller has put that argument on the stack. And this function here returns 2 values, so your function is expected to return these 2 values. And this is checked by the compiler. So there's it's checked by the compiler. It's also checked by the client library when you load it. But at the moment, the compiler checks the stack, but it doesn't lay it out because I don't know how to do that. I'm hoping that at some point in the future, someone else who knows more about compilers than me will be having to write these notes, and they'll go, this is easy, I'll do it. But not now. Okay, I'm not going to walk through this function, but this just kind of exists. This is to point something out. This is another thread debugging note to get the address of a TLS block or thing, to get some kind of value from thread local storage, or the address rather. And I've put this function in just to point out that what this one's doing here is it's calling another infinity function, but this function is in the runtime linker. So it's kind of to illustrate that they kind of come from multiple sources. Like at the moment, libthreaddb is accessing runtime linker internals in a way that means that if you were to have a libp thread from 1G libc with the runtime linker of another with different structure offsets, it would fail. Whereas if you're using infinity, it's accessing it through an infinity function in the runtime linker, so it kind of opens the door for that kind of thing to be done. I'm not sure if there's any demand for it, but it means it's kind of safe.
How is linking these, like, they're in different shared objects?
Mm-hmm.
How does this find the other one?
So when your tool kind of attaches or starts to inspect your process, the way I'm doing it in GDB is it's looking at the actual files that you've loaded. So when GDB goes through and starts adding the objects of the application that you attach to or whatever, it's going to add the runtime linker, and then those functions from the runtime linker get given to the client library, and then it carries on and it adds the thread library and it adds those functions to the client library. And I guess the answer is the client library links them. There's kind of a kind of callback mechanism. So when you kind of give the client library the encoded functions, and then it tells you that functions have become available. So a function only appears in the debugger when, like in this case, if you added the encoded form of this function, but the runtime linker function wasn't there, then this function would not appear in the debugger. So the debugger would kind of assume you had no TLS support. So the functions arrive at the debugger kind of more piecewise than they do with libthreaddb. It's like
the idea is that Infinity is platform independent, I understand. But when we see calls to, for example, _link map TLS mod ID, that looks like relatively specific. We will probably not find this if we use GDB to debug a Windows application.
Well, no, this thing here is the name of another infinity function.
Okay,
So
we reuse some of the names.
Yeah.
Okay.
So.
But this then should map then on, I don't know, I know nothing about Windows, but is the thread, let's say, mechanism and so on used on Windows for TLS mapping this structure?
Well, again, I don't know anything about Windows either, but the kind of idea is that the set of functions that the debugger sees is it's kind of like an API. So if the debugger sees that you've got this function thread get TLS address, then it knows that concept is there. So it doesn't matter how this is implemented. Like this is the implementation from glibc, whereas a Windows implementation would almost certainly look completely different, and it maybe wouldn't have the concept of a runtime linker or a module ID. I don't know. Does that answer your question?
Yes.
Cool.
I misunderstood the level at which this was done. No, it's clear.
Let's have a quick look. This is a test case that for one of the functions. it's kind of the way I've been doing the test cases is this implement thing just says it kind of this like stubs out all the functions that it's going to use, then it calls the function and checks that the result is as it is. It's like it's a test case.
So this is so you have a Python wrapper of the clamp library. Is that
Yeah.
okay? Yeah, because okay.
So yeah, when
This Python, yeah, you're calling the library.
mhm. Yeah, the current status of all this lot. The note compiler is complete, but it needs documenting. The note tester is complete, but it needs documenting, and it needs more tests. The client library is complete, but it needs documentation
Can see the pattern.
and some more tests. The client library actually has quite a lot of tests, but it doesn't have tests that would validate the specification, which in itself I haven't completely finished writing. But like the specification says that this bytecode should do exactly this and exactly that, and so I need to write a lot of tests for bytecode that doesn't do that, which is not there. I have the stuff to create the broken bytecode, but I don't have I haven't sat there and churned away at writing them all yet. I've got a set of glibc pthread notes. The ones that GDB needs, they're all complete. Most have tests. The API that they export isn't documented, but that's relatively simple. I don't know if there's any glibc people here, but I'm hoping to get a patch mailed by February the 16th. That's my date. So I'm kind of working on getting this all kind of in fairly soon, hopefully. The libthreaddb, the kind of integration part of it is there. There's a little GDB modification that it needs, which is currently native only. So that's future work. And yeah, the GDB integration bit that I mentioned earlier is kind of post 1.0. So it's not done yet.
How stable is the node format and the bytecode?
I'm hoping very stable. It's because I can't even remember why I decided to call it Infinity, but as things progressed, I spent a lot of time thinking, if something's going to change here in the future, how do I make it so that it fails gracefully, so that it's hopefully got a lot of kind of built-in stuff so that you can easily say that this is not relevant anymore, this is unsupported, or it is now supported, so that older stuff using newer features can gracefully fail. Time will tell if I've actually managed that. Let's see if I can find. I show you a demo, but it's not very exciting because it's just it's essentially it looks exactly like GDB normally. Let's see if I can get this. Come on. All right.
Are you seeing something we are?
Yeah, I'm trying to get this to. There we go. My mind went completely blank and I couldn't remember what key. Hello. Did that just change colours then? That's horrible to see. So we change the colours. That looks good. Is one of these going to be black or white? No. It's there, isn't it? Grey and black. Black and white. Right. Okay. Can everybody see that? Okay, so there's an example process. 573. And so if I open another tab, is that gonna, oh, where am I? Okay. Is that gone back to being small again? So if I go TD and tell it to load the should have done this in advance. Okay. There we go. Jeez. This is going to be such an anticlimax. What did I say it was? 573. There you go.
Wow.
It's got a block. And we can go info. This is a statically linked program with 2 threads. And so it's also got a TLS variable, which is
So, but wait a minute, it is
There you
loading libthread.db.
it's loading libthread.db, but that libthread.db is using Infinity.
Exactly. It's keys one. You know, the one in WorkGLT.
Oh, it's a
Infinity.
fake.
Yeah, because at the last time I did this talk, everybody said, well, this is great, but can we actually have a libthread.db on our
I
system?
want the new stuff looking like the old one, right?
Yeah. And
Change without change.
I'll show you if I show you it with the debugging, like tracing switched on, type all that stuff in again. What was it? Set libthread.db search path work. glibc. Okay. This actually hurts. Save. You know, 573. You should see a ton of bytecodes get executed now.
Oh,
So there you are. There's stuff happening. So if I do that, print the TLS variable again,
uh-huh.
you will get some more bytecodes. Not a huge amount. Like you can see, it's actually quite a complicated. Where's the start? The start is about there, and it's going into this function get TLS base, and then it's also calling. It's going into it goes into this. This is all thread debugging stuff, but then it goes into the runtime linker notes and starts pulling stuff out from there. And yeah, prints the number, and that's it, I think.
So this is probably a silly question, but the client library is actually running the bytecode? Is that,
Yes.
That's right, okay.
Yeah, all these here's that's kind of the bytecodes column. The ones with IX are kind of extra ones that the client library put in. They're not actually in the note.
Or drop extension.
Well, no, these ones are in the thing.
Did you see Andreas talk on the pieces?
No,
Oh. Do you implement DB of these?
what's that?
Probably
no.
not. Let's probably answer is no. You- yeah. Yeah.
Yeah. Okay. I'll just put all this stuff on the screen, and then any further questions I will answer.
I have a couple questions. One is, does this let you remove libthreadDB from GDB server?
Currently, no, but it would kind of at the moment the way it's going to work is you load GDB is still going to load libthreadDB, but the next thing that I have in my kind of sights is the multiple namespace thing, and there is no debug library written for that, and I don't intend to write one now. So
Like DLMO?
yeah. So what my kind of once this is all in glibc in the libthreadDB and in the libpthread, my kind of next thing is then to make GDB access the Infinity functions by itself without needing libthreadDB, and then it will be able to do it, and it will all happen in GDB. Will it happen in GDB? No, it probably would make sense to have it in GDB server as well.
Yeah, I think it would be nice to have it not in GDB server,
Mhm.
just because that's an added thing. If you have a GDB server implementation, it's just an added complicated thing it has to do.
But then you would have so you have your GDB server, and your application creates a new thread, and GDB server has to communicate with GDB to handle that,
But, I mean,
or does it?
GDB could already, it's just evaluating some little script and getting some stuff. GDB could do that.
Yeah, it would be totally possible.
Say what?
If libthreadDB is implemented internally using Infinity, there's
Right.
nothing blocking GDB using a libthreadDB that then
Right.
interprets the opcodes
Yeah.
in the host, even if connected to a GDB server. Then you just have to load some version of libthreadDB that's compatible enough with the functions defined by Infinity. If you load some version that's using some opcodes that's not familiar with the opcodes that are in the binary, it will fail. So if you load a new enough libthreadDB, should be backwards compatible.
Yeah, I mean, I guess the kind of ultimate idea is that GDB just won't need libthreadDB. It won't ever pick it up.
That it just then it becomes a little implementation detail. It's just that piece of code that's a bridge between GDB and the client's Infinity library. It's either a chunk inside GDB or it's a separate library.
But
It's the same thing.
yeah, for thread,
Conceptually, it's like you pick libthreadDB and copy paste it. The new implementation. It's like if you copy it inside the feed, right?
yeah. Well, yeah, but like the for just thread debugging, yeah, it's no difference whether it's in libthreadDB or whether it's in GDB. But once you start adding extra things like DLM open, it doesn't make sense. That obviously doesn't live in libthreadDB. It doesn't make sense. It doesn't make sense to me to write a new library.
To me, it does. Because then you're going to expose a few entry points in Infinity terms, like get TLS address with threads maybe needed, and those will be defined entry points, defined in terms of Infinity functions, right?
Yeah.
And something will need to be aware of these entry points. And there will be some C code that will call into some Infinity interpreter saying, run this Infinity function. And there will be different tools that will want to do the same thing and call into the same entry points. Thread debugging. Both GDB, LLDB, and other debuggers, that'll do whatever. they'll all want to call the same entry points. And that can be wrapped in a small shim library that exposes like 5 C functions,
Mhm.
and you don't see infinity at all. Right? It's implemented inside that shim library.
Mhm. Yeah,
It saves work for the different tools.
to say, well, I guess like they can do kind of different things. Like there's once, like at the moment, all the thread debug stuff is in its own block, whereas once kind of debuggers can actually access just a single infinity function, then there's no need to have like functions blocked up like that. Like, what if you want to just access one single structure offset? Do you want to write a whole library for that, or would you like your debugger, your tool, to be able to call a single function to get that?
Well, I see it more in terms of glibc is going to expose a set of infinity entry points, and
Mhm.
that's going to grow over time.
Mm-hmm.
So you could have a matching library, just like libthreadDB, but for
libglibcdb.
libdldb. And that will grow entry points just like the infinity points grow.
Mm-hmm.
And
Yeah,
I see that as a viable option. Maybe I'm wrong.
yeah, I think maybe I kind of need to sit down and talk about it and a little bit more comfortably than standing here, but like.
I still have more questions.
All right.
Okay. My next one is, are these notes like in a loadable section? Get them out of inferior memory?
No, not at the moment. There's nothing to stop them being made that way if you want them to be. They're not allocated, is I think what you're
Yeah, I have to
asking.
give it to
Yeah, they live on the disk, but they don't live in memory. I've kind of made it that way at the moment. I've made it that way at the moment purely because all current for GDB to do this stuff now, it needs the files on the disk. So it didn't make sense to put the stuff in memory for all inferiors when it doesn't make GDB be able to do anything extra. But like the client library it doesn't care where the functions come from. Like, it doesn't care whether they're pulled out of memory or taken from disk, because you just give it to them. So
I was just wondering about crazy. I had two ideas. One is, if it's coming off the disk, can you attach to a running program whose executable has been deleted? You know, and then if it's coming from memory, is there a security issue with having an allocated section that has pointers to TLS things, because some of that is pointer mangled in glibc.
at the moment they're coming from the disk, and so you can't attach to something that is executable has been deleted. It kind of went through my head. Oh, you could do all these things with it, but then if the executable has been deleted, there isn't a lot you can do with it. And from GDB terms, like if some other use case has that it is useful, the notes are loaded into memory. I mean, the other thing is things like I think the thread debugging stuff is, I don't remember where it came from, but there's a kind of requirement that it can work without debug info installed. Whereas some of the other things like pretty printers, maybe if the pretty printers used infinity functions, then those infinity functions could go in the debug info if there was a lot of them. So
I have one more crazy question, which is, like, sometimes people want to be able to use GDB and like debug something that has green threads, or there was like those Linux patches for debugging the Linux kernel to understand its thread system. Is it possible that those systems could export these same functions? Would that actually work, or are there other dependencies on the thread IDs in the system, and so you still need to teach GDB stuff to understand?
I mean, if if the threading system you're interested in can fit into the API of the notes that are currently there, then yeah, I guess there will be no extra work. But I'm not familiar with any other threading systems.
There's
So
two levels of things here. If you want to do that, like for supporting better support for Go routines in GDB. Currently, GDB is not aware of Go routines. You debugging Go lands inside the runtime. The scheduler decides to change where the Go routine is running. And to support that, you need to come up with some API that debugger queries, like some higher level entry points, like please tell me what is the kernel thread this Go routine is running on right now, or I want to schedule this Go routine that's currently unscheduled. Please hack the scheduler to make it runnable right now. But these are the entry points you need at the level that the debugger needs to access. How it's implemented behind the scenes. How does that component discover the structures inside the running program, where to poke in the scheduler? How do you describe those structures? That can be Python, that can be C. They have disadvantages. They can be infinity. And then there's the advantage that it's architecture independent. So an infinity solves that layer of architecture independence, but you still need the higher level entry points. You need to be designed and specified.
Yeah.
That's
One other comment before you asked about moving link thread to GDB. There's one disadvantage to that, which is latency related, because you ask for print me variable, TLS variable, and you notice the bunch of opcodes that ran when they showed that we logging enabled, a bunch of memory accesses back and forth, just follow some pointer chasing.
Yeah.
If we do that on the server, then the host is going to ask the server, give me TLS base. That's one round trip on a potentially slow latency link, a few milliseconds perhaps. If you move that into all this imputation to the host, you may have milliseconds for each of those. And if you have 100, then it can be noticeable. It can slow you down.
Yeah, I'm just thinking like, first of all, I added the thread DB support to something and it's a nightmare. And I don't want to ever deal with that again. It'd be nice to just remove it,
The worst was the callback interface.
Well, and then there's, the callback stuff. But it seems to me like you'll need something like that with this scheme because notes require you to find the elf file and extract some section from it. But like GDB server doesn't know how to do that. And generally, some other implementation probably wouldn't know how either because nothing needs it right now. Right? So you can either make that a new requirement or this libthread db shim will have to use that same symbol callback API to just look up a different symbol, like a magic symbol meaning send me the notes or whatever.
So,
Does that make sense? In practice, it's not complicated to parse an element between lines.
I mean,
but it's just some code. You have to know about proc or
the way I imagined it working for GDB server was that GDB and GDB server would both have the Infinity client library, and GDB would feed the notes to the one that it held. So GDB will be passing the elf, because I guess with GDB server you also have the thing. Sometimes you might have like some like stripped binaries over here, and you have binaries with symbols over here. I think that's pretty common. So the GDB would be loading the notes and then sending them over to GDB server, which would then it would maintain its own copy of the kind of like each GDB server would have its own copy of the notes, and they would execute there to avoid the kind of latency. GDB would handle any symbol lookups that it had.
Yeah, I mean, if it
The
did
relocation.
something like just shipping the data over, and it was like that part of the GDB server, the callback thing is also just, it's very messy to implement.
Yeah.
You know, the
Don't ask me why it's done that way.
Yeah, and you know, it is how it is, but it'd be nice if something new didn't work that way. It worked. It's more like,
It's bizarre because the interface was copied from Solaris, and the Solaris interface is function pointer based.
yeah,
Register this callback.
right,
This is the normal thing.
yeah. Well, I don't mean the libthreadDB part, I mean the part about GDB server. There's a special thing in the protocol to do this dance to get symbol back.
Oh, that little.
Symbol lookups and then
There's some. I know the bit you mean. That's.
keeps it state. And it's just kind of complicated and messy, and it'd be nice to have it be not messy.
Yeah, we can talk about that. That was,
Yeah.
Understand and
that's the Q symbol.
Cool.
You can only do it at some specific point.
Right, cut. Is anybody else? Okay.
Notes compiler that would point code outside of the web. They might be needing to you want to use it on L5.
Yeah, I've tried to make it like as generic as possible. So like, yeah, at the moment, you know, the note compiler uses GCC, which generates ELF, but there's nothing to stop. There's nothing forbidden it in the standard or whatever, the spec. It is ELF at the moment because that's what it is. But they're self-contained units. They don't rely on anything else from the ELF file. They don't need the byte order or anything like that. So they exist kind of on their own. Cool. All right. Thank you all for listening.